everybody, welcome back to Teach Me to Science. My name is Saren and today we're going to be talking about reaction steps. First we're going to talk about reaction steps, then we're going to talk about elementary steps and rate determining steps, and then we're going to associate all of the above with rate laws. When I was first learning about general chemistry, it came as a big shock to me that one single reaction can occur in multiple steps. But that's how it happens in real life. Our reactions occur in multiple steps. Here I've drawn an example of what's called a reaction mechanism. Reaction mechanisms can vary from relatively simple like this to extremely complicated. If you've taken OChem, you know what I mean. There are a couple of important things to note about my simplified reaction mechanism. My overall reaction is A goes to D. This means that with all of my steps included, my overall reaction has to add to A goes to D. I already told you that reactions occur in steps. The simplest of these steps are called elementary steps. Elementary steps are the most broken down, simplest way for a step to occur. And each elementary step can be described by a rate law. This describes the rate of that specific step in the reaction. And combining all of the rate laws of each of the elementary steps should give the overall rate law for the entire reaction. It's important to keep in mind that when you're writing a reaction mechanism, it has to be reasonable. This means that the number of molecules interacting is below 3. If you think back to collision theory, molecules must collide in the correct orientation for a reaction to occur. The chances of more than 3 molecules all colliding together in the correct orientation is slim to none. This is why we say the number of reactants has to be reasonable in each elementary step. So if each elementary step is described by a rate law, then each elementary step has its own rate. And one of the steps has to be the slowest. The overall rate of the entire reaction is determined by the slowest step. This is called the rate determining step. Think of it like a relay race. How quickly the team finishes is determined by its slowest runner. Alright, there are a couple of important things I want to note here. In an elementary step, the reaction order in the rate law of that elementary step is determined by coefficients. When we're writing the rate law for the overall reaction, we cannot use coefficients to write the reaction orders. And because the overall rate of the reaction is determined by the slowest step, the rate law for the slowest step is the same as the rate law for the overall reaction. We can use this idea to determine which of the steps is the rate determining step, and vice versa, you could use the rate determining step to determine the overall reaction rate law. Here we're going to use the reaction rate law to determine which of the reaction steps is the rate determining step. The rate determining step will have the same rate law as the overall rate law for the entire reaction. This means that the first step is the rate determining step. I hope you enjoyed this video. If you could, please like and subscribe to my channel. I would really appreciate it. Bye!